Hi everybody, this is Kiran here. Let's get into the session. So the session is about Apache Hive. So basically we will try to cover these three facts in today's session. So what is Hadoop? What is Apache Hive? And let's try to see how does that help in our industry on a day-to-day basis. So if you have to see what is the first and foremost concept, what is Hadoop? All right. So predominantly you would have seen the world is significantly changing from data starving to data carving, which means the amount of structured data over a period of time is increasing to a great extent. So 20 years back or 2 decades back, probably the world had very limited structured data. And I would say the structured data in the world till late 90s was only 2 to 3%. Today, in last 2 decades, the structured data has increased to around 21%, which means we have added 20% of the data in last 2 decades. So you can now imagine how much of data is getting added year on year. And especially last 5 to 8 years have been significantly enormous amount of data getting generated. It can be in multiples. So the data growth rate is roughly around 600 to 800% year on year. So with this much of data coming in, we need a framework which can help us to collect and store. So Hadoop in nutshell is a framework that allows us to store and process the large data sets in parallel and distribution fashion, which means you might be seeing what is happening on your social media sites. At any given point of time, the Facebook or WhatsApp have more than billion parallel users who are doing a read, write, or post activities, which means they will have to enable all the three things in parallel, which means the data collection, data storage, data processing, which needs to happen. To do that particular things in parallel, Hadoop comes very handy. So this helps you to do the storage in a distributed file environment, and MapReduce helps you to parallel to process the data parallelly and distribute the processing, which means you don't make load centric, but you distribute the load so that at any given point of time you are not really having any challenge. That way Hadoop framework allows you to store and process large data sets in parallel. And if we have to see a scenario, what happens basically, if you see this, a manager managing number of 4 people, he assigns the product to each one of them, which means that's what happens in a typical project management, which means somebody are working in a front end application, somebody are working in the middleware application, somebody are working in a back end application, somebody is working with integrating all of these particular things. This is basically what we get to see in a MapReduce application, which means you are getting your inputs from multiple sources and parallel processing is happening. And then the manager, whoever is responsible for the project, who is your you can correlate it to your Hadoop framework, he is the one who balances the work schedule, manages to see how exactly the work can be distributed, and then he makes what all the individual or small activities which each one of the resources perform, he tags them. So for example, John from project A, James from project B, Bob from project C, and Bob from project D are doing in silos their activity, while the manager is working in parallel to make the things happen. That way a large activity at a given time, in sense you can also, for a minute we can say, it is basically working against time. The reason why I say this is basically at the same time multiple heads are working. multiple resources are contributing to their particular task. That way you can make the things happen. So once this framework is happening, imagine if there is any downtime or somebody falls sick, then that particular reassignment or reorg is done by the project manager. So basically there comes your coupling. Basically you then reorg your thing. So if you see project A and C, John gets to do, project D and A, Alice gets to do, and James was replaced with somebody person. So that management of activity is what happens seamlessly with your framework, this big data framework. Saying that particular thing, now if you have to see technically, this is the master node, who is the project manager becomes the master node. All other resources who are enabling the final dedicated activity becomes the slave node. So you have the slave nodes, you have the master node, and master node usually tries to mimic between what is happening versus what is not, and then gets going. This way, your master slave architecture gets addressed. Then if you have to see the next thing, basically what happens here, we are trying to show that pictorially. So this was with regard to the project manager, with regard to the resources, and the same thing, it becomes a master node with associated slave nodes, and it's a bidirectional information transfer between the master node and the slave nodes. That way whatever is happening at the slave nodes in turn gets reported through a master node, and master node keeps the track of all the parallel processing. This particular activity of managing large data sets with parallel processing becomes your framework of Hadoop or big data. So with this, we will have to see what is the need for Hive, for which we will have to see what exactly is the whole benefit of using Hive. So here, if you happen to see some numbers in terms of how much of data is getting generated. So for example, on a Facebook, the number of users, a billion users, 1000 terabyte of data, 1 lakh queries, 500 million photos. So we all know with every increase, or rather with very latest models, the megapixel of the cameras are very high, and high megapixel cameras are usually of large space, which means their pixel is very higher. So with this much of data getting loaded, and you would have all seen Facebook is a bottomless page. You keep going, it doesn't end, which means it's continuously generating data. This generated data has to be stored, and parallel processing has to be done. For this particular thing, you will have to have a framework which is continuous in nature, at the same time which is not redundant and which does not break. And if it breaks, the reassignment from the master to slave has to happen seamlessly without hindering the user experience. So to do all these particular things, we need a placeholder which can help us to see how we can do this. So that's where Hadoop with Hive comes handy. So basically the databases can be anything. It can be an SQL database, it can be an Oracle database, but the data quotient which is getting generated is very large. When that large data quotients have to be admired and admitted, you need to do the things with an additional enabler, which is Hive. So that way you are using your Hadoop with your Hive to make the things as seamless as possible. So if that is Hive, then what is Apache Hive? All right, so let's try to see what is Apache Hive. So if you have to see what is Apache Hive, basically Apache Hive is an open source software built on top of Hadoop to provide easy data storage and analysis in style of SQL. So most of us would know the database. So it is a simple RDBMS, relational database management system. So what is the good part of a relational data storage mechanism, RDBMS? The way we can write the data, change the data, retrieve the data is through simple queries, which means we have been we have got used to the SQL approach so heavily that this can be done in the same fashion. So that way Apache Hive is also an utility which sits over and above Hadoop, which can provide easy data storage and analysis. So storage is the right function, analysis is the read function basically, which we can retrieve from the data which is stored in the final database. That way Hive is very heavy attributed in terms of how you can really write and read the data using the Hadoop framework. So that way Hive has become significant in terms of data warehousing, used for data analysis, built for SQL users, managers querying structural data, simplifies the abstract load, and no need to learn Java or Hadoop API, which means basically your request for the details becomes from an user friendly perspective. You don't have to really do what exactly or rather how a technical person can do, a relatively non-technical person can easily handle. So if you have to go ahead and see the usage, so one thing is basically you can always go and see how the world is adapting for this new technologies. You can go to Google Trends. So this is the website which gives you how much of searches are happening in what geography for what kind of keyword. So if I go to Google Trends and type the Hive or Apache Hive, let's get to see the real time what exactly is the trend for last 5 years. So if I say Apache Hive, so if I select or rather let me make it Hive or, and if I select for last 5 years, and if I also compare it with a like-minded thing like Hadoop, okay, Apache Hadoop. Okay, so you get, okay, this is basically I have selected only for United States. If I go here and select for worldwide, you get to see in relation to Hadoop, the Hive has relatively higher searches in last 5 years. And if I have to come down here and see the timelines, basically this is how it works. Okay, let me go little okay. If you see here from 2015, the Hive basically has much more significant searches. So when do people search? When they are using or when they are technically trying to understand the search. So Google Trends clearly indicate the higher adoption rate because of that user flexibility. So like we see, these are all the placeholders what are where Apache Hive is used. So saying this, let's see what exactly is our applications of Hive. So where exactly we use Apache Hive? So there are endless or rather so many Hive applications which you can think of, which is in data mining, document indexing. So predominantly imagine about a cloud server which is of a large storage, and their retrieval becomes such a challenge. So until and unless you don't do your document indexing, you will not be able to address this. And predictive modeling, which is used in your data science and machine learning concepts, where you will have to feed in the data which can be consumed for your downstream applications. There you use your Hive, and then you get to your business intelligence. So what is business intelligence? Predominantly trying to enable business to take appropriate or amicable decisions for the given options becomes your business intelligence, which means the options are ample. Today's business decisions are very complex. So until and unless you enable a tool which could consume all your data and influence, you will not be able to do this thing. So that's why even for business intelligence, you happen to use your Hive applications. Then coming into log processing. So we all know there is a monitoring for all the activities which are 24/7. Probably it can be a simple banking project, or it can be your social media, it can be your ATM services, it can be your mobile phone services. Where the world is becoming into digital transformation, your log collection is one of the biggest tasks. And whenever there is a log collection, the log processing has to happen. So for log processing with such a large amount of semi-structured data, you require an application which can do all these things very helpful. So you get to do and see all these particular things for your log processing. So some these are at a very high level. Data mining, we all know, right? Predominantly it is about, there is a humongous amount of data, but you just cannot consume all the data. You will have to mine what is needed, so you have to do your data mining. So for that you use your Hive applications and get going. So then coming to some of the features. So what exactly Hive with such a high relevance? So if you happen to go and see the SQL type queries, because we already discussed, it has a very close association with the database concepts. So SQL type queries helps you. And then your OLAP based designing, in sense the way the structure is designed makes very well, or rather self-contained, self-sustained query builders. So that's why it is much appreciated and much used. And with regard to the latency in terms of query to result, you have a significantly lower latency rates, so making the whole application very fast. Then scale up. Even Facebook was created, probably they would have never thought that they might have to process 1 billion users data at any given point of time. Forget processing 1 billion data at any given point of time, they may not even have thought that there might be 1 billion people on their network, right? But for that kind of things, you will have to plan a system which can be easily scaled. Next, extensible, right? So basically, so this goes very well tagged with your scalable. So whenever you have to extend it and connect with other associated things, so probably if you have to see this way, 5 years or 8 years back, Facebook was only an application which was available a browser based. But today the app traffic has overtaken the browser traffic by 3 to 4 times, not even percentages, 300 400%, which means if you are build an application which is only browser based and not compatible with your app based, probably it would have been a biggest showstopper. So that way you will have to make things which is extensible, and Hive supports it very well. And ad hoc querying, because there are two types where you can build for regular queries for your repeated reporting, but you will need an tool which can help you to mitigate the ad hoc querying. So that is well structured and well supported using your Apache Hive. That way you get to see and do the things. So basically these 6 factors make Hive very advantageous in terms of why, what, how questionnaire. Then let's get and see the Hive architecture at a very high level. So basically an architecture looks at this 3 stages. So you have the lowest level Hadoop distributed file system, over which we use the MapReduce using the MapReduce techniques. Then you have all your external sources like your web UI, the Hive server, Hive driver, Metastore, CLI, all these things, on which your JDBC driver or the Trip server or the ODBC drivers sits on this. So basically they are interlinked in a fashion which can make things much easier. So it is a straightforward approach. Many times you can also call it as a 4 level architecture. So the Hadoop file system is your underlying things on which you reorchestrate the whole Hive framework to make things as seamless as possible. So trip server is a server which can integrate with your downstream applications of your web UI or server, and if at all it has any upstream applications like external things, it can be as simple as an Android app or a mobile iOS app. So this balancing the trip server usually accommodates. So that way you are covering the whole framework. Okay, so saying this at a very high level is the architecture of Apache Hive. So with this, if you have to go and see what is the components which are associated. So if you have to see the components, let's get to see the Hive components. Basically, the first and foremost component, innermost, is the shell. Then comes your meta store, then comes your execution engine, then the driver, then the compiler. Basically this is the five components which makes the Hive a very editable a tool. So it starts with the innermost shell. So people who have been using Python or any other interpreter based programming language know what is a shell. So it is basically a single line executor where commands are executed. Then comes your metastore, where the data what you are getting is in a format which can be consumed. Then is your execution engine, which is a layer which helps you to execute, and this is where the machine level programming to your application programming also gets re-orchestrated. The driver, which acts as a connecting layer, the compiler basically compiles the code. That way these five components are your Apache Hive components. Then if we have to see the whole thing, basically if we can generate any of the upstream data, right, like your Facebook data or WhatsApp data or your Twitter data, we can put it onto an Hadoop thing and see the whole environment. So this way, in a nutshell, what we try to check today is basically we try to understand the components which are associated with your Hadoop and the Apache. So basically this was a session to get you an introduction to understand some of the big data and the reason why that usage is becoming so heavy. Okay, so with this we probably are to a stage where we have discussed about the points what we had planned for. I think we are good. So thanks everyone. Be safe. Bye.